What's up, guys? Today we're doing a question asked by Vishal. This question is currently being asked by Facebook, Amazon, Google, and Uber, and the question is called Course Schedule 2. Cool, so today we're doing a question called Course Schedule 2. This question is currently being asked by Facebook, Amazon, Google, and Uber, and I actually picked to do this question because this was the first question I did when I was studying for my Uber interviews. And it's a really helpful question because it has a lot of information on graph theory in it. So the problem description is there are a total of n courses you have to take, labeled from 0 to n-1. Some courses may have prerequisites. For example, to take course 0, you have to first take course 1, which is expressed as a pair 0, 1. Given the total number of courses and a list of prerequisite pairs, return the ordering of courses you should take to finish all courses. There may be multiple correct orders, you just need to return one of them. If it is impossible to finish all courses, return an empty array. So for the input 2 in the list of lists, 1, 0, you can return 0, 1 because 0 is a prerequisite for course 1. So an order that you could take them in is 0, 1. So basically what this is asking is if you imagine each class as its own node, and then each prerequisite of a class being some directed edge saying I can go from class 0 to class 1, like in our example, if you can create a directed acyclic graph, or a DAG, in order to take all the courses. So DAGs are actually really useful in computer science. They're used a lot in task scheduling, and basically what a DAG is it's a graph that allows you to traverse all of the tasks but has no cycles. That's why it's acyclic. And then what a cycle is it's a graph with no backwards edges. So basically, if we can prove that we have a DAG with no cycles and then our graph has no backwards edges, then we can prove that we can find a successful ordering to take all the courses. So in order to prove that there's a backwards edge exists when a node points to a parent or ancestor node. So in the graph, 1 points to 2, points to 3. That's a directed acyclic graph because no child nodes point to ancestor nodes. But if we had a graph 1 pointing to 2, pointing to 3, and then 3 pointing back to 1, that would 3 would be a backwards edge because 1 is a parent of 2, and then 1 is an ancestor of 3, but 3 points back to 1, which means it's an ancestor, and we don't have a valid DAG. And the reason that wouldn't work in this case is because you couldn't take class 1 before you took class 3, and have to take class 3 before you took class 1. So we just want to return an empty list. So in order to code this up, it'd just be 2 simple steps. Step 1 being build a graph. And maybe they aren't that simple. But then step 2 being validate if it's a DAG. And then actually I'd want to do this with a depth first search, because a depth first search would give us a better theta n runtime, because we'd be able to traverse the entirety of our graph all at once in one pass, in the best case, in order to see if we have this valid DAG. So I prefer to do a depth first search for that. So I'm just going to make 2 helper functions to do this, self.build graph, and I'll take in my num courses and prereqs. And then in order to tell that I haven't seen a node before, so going back to the example, 1 pointing to 2, pointing to 3, and then 3 pointing back to 1. While I'm traversing in a certain call to my isDag DFS function, I'm going to keep a visited set. So the visited set will tell me all of the nodes I've visited in that traversal. And if I've visited in that traversal, then I'm just going to return that empty list. So I'm going to get back a graph and a visited set. And then in here, I'm going to make some ret array. And I'm going to say for child in, or I can just say for node in graph self.isDag, and I'll say isDag DFS because I'm doing a DFS, and pass in my current node, my ret array, my graph, and my visited set. So if this evaluates to false, so I'd say if evaluates to false, then I'd want to return this. Otherwise, I'm going to return my ret. So let's implement first build a graph, and then we'll implement this isDag DFS function. Def build graph, self num courses, prereqs. So first I'd want to initialize a graph and a visited dictionary. And then I'd want to say for I in range num courses, graph at I is equal to set, because I want a set of all of the edges that it points to, and then visited at I is equal to 0, because I'll set the visited dictionary equal to 0 when I haven't visited it, and 1 when I have successfully visited it, and then negative to -1 when I have visited it in the current DFS traversal, but I might see it later. So if I have 1, 2, and 3, when I'm at 2, I'll have -1. I'll have 1 set to -1, but when I've finished the traversal and gotten a 3, if I haven't pointed back to 1, I'll set 3 to 1, then I'll set 2 to 1, then I'll set 1 to 1. So I'll set that to 0, and then now I'll say for P in prereqs, and then I'd want to say that the graph at P of 1 is a prereq of the one at P of 0, so I'd add P at 0, and then I just want to return my graph and my visited dictionary. So now that I have that going, I want to implement def is dag dfs, and I'd want to pass in self node ret graph and visited. So first I want to check if visited at my current node is equal to 1. So I've successfully visited it in a traversal and I have not pointed back to it. So I could just return true. And then the other case would be if visited at node equals -1. So I've visited it in the current traversal. So if in the 1 pointing to 2, pointing to 3, and then 3 pointing back to 1 case, I would see that 3 points to a visited node that is set to -1. So I'd return false. And then back here I'd return an empty list. And then otherwise, I'd want to set the current node in this call stack to -1. And then I'd want to say for child in graph at node if self dot is dag dfs self child ret graph visited equals false. I'd return false. Otherwise, I want to set the node I just looked at to be 1, and then I'd want to append my result, append my current node, and then just return true. So what I'm doing here, because the way a DFS works, I'm going to be appending the one that's actually last in the call stack. So I'll actually be appending the order in reverse order. So what I could be doing is say ret.insert at index 0, but the .insert function would create a new list every time, and this would be n runtime every time I needed to append ret. So instead I'm just going to append it in reverse order, and then here I'm going to return my list backwards so that I can only have one list and then turn it backwards to save time complexity. So cool, if these steps work correctly, hopefully this should run. So let's see if there's any errors. Okay, let's try to debug this. So I shouldn't call self on this. Great, and it looks like it works. Let's run it on all the tests. Awesome, and it works. Cool, so I hope that was helpful. If you have any questions, put it in the comments down below. In the next video, I'm going to be doing a BFS problem, all nodes distance k in binary tree. So if you want to see that video, I'll link it above. But I hope this was helpful. If you guys have any questions, just let me know, and I'll see you next time. Peace.